So now once we have all of our triangles drawn and all our points connected, should look something like so. What we want to do now is start finding our every 2-foot contour interval. Now, looking at these elevations, I see elevations running, I think my lowest one here is 922.45. The highest elevation I'm looking at is 935.63. So what I would be looking for when I mean 2-foot contour intervals, just jot this down up over here real quick. I'm looking for the 924, 926, 928, 930, 932, 934. Okay, those are the contours that we want to look for. That's your contour interval. We have intermediate and we have index contours. In the case of this 2-foot contour interval, the 930 is going to be your index contour. So we're going to make that a touch different as far as line type is concerned. So I want to start looking at every one of these triangles and determine where do I find these elevations, these contour lines at. If I started here, 923.81 and 928.89, I'll have the 924, 926, 928 contours. I'll have 3 contours that fall between these 3 points. The way we do this interpolation, or what I think would be the easiest way, is this one equation right here. Rise over run equals slope. That is going to be the first thing we're going to want to find and solve for, is the slope. Your rise is equal to, I'm just going to abbreviate, your difference in elevation. Okay, so meaning these 2 points here, what's 928.98 minus 923.81? I did not leave my calculator here close to me. $928.89 and 923.81 minus. That gives me a rise. In this example right here, for this one line, my rise is going to be 5.08. Run, what's the run? Run is equal to your horizontal distance. Well, we will take our scale and we are going to measure that. Let's see, 50, 55, 56, 57. So we'll say 57 feet. Rise over run equals slope, which gives me a slope of 0.89. That slope is the difference or the rate of change in elevation from one point to another. So we're looking at this from a plan view, as if you're looking at the top down. If I was to flip this over sideways and look at it from a profile view, meaning the elevations, I'm looking at a triangle that looks something like this here. This top part of this triangle, that's this elevation we're looking at of 928.89. The elevation down here at the bottom for this triangle is 923.81. the rise, the difference in elevation, this minus this side of the triangle is 5.08. The run is the horizontal distance, which we took a scale and measured to be 57 feet. So the slope falls right here. This would be 0.089. I wrote that down incorrectly. 0.089. That's a big difference. Okay, so that's the first step right there. Now, what we want to do is find where's the 924. I'll just mark that like, say, right here, 924 contour. We want to find the 926 and the 928. I just randomly marked those on my triangle up here. Well, what do we know? We know what elevation we're looking for. We know our low elevation, so we can solve for the rise. We know our slope. We need to solve for the run. So if I do a little mathematical gymnastics here to isolate run on one side of the equation by itself here, we come up with rise divided by slope equals run. Okay, so let's break this down into a smaller triangle. 924 minus 923.81. So we have a rise in this case of 1900ths. We're going to divide that by 0.089. And that gives us a distance of 2.13 feet. Not very far. So now I will put my scale on here, measuring from our low, go over 2 feet. Here's where my 924 contour is crossing that. Okay, let's look for 926. 926 minus my 923.81 gives us a rise of 2.19. Again, divided by the 0.089. 24.6 feet. So I will take my scale again, starting with 0 at the low point. 24.5 feet. So right about there. This point is my 926. How about 928 minus my 923.81? Gives me a rise of 419. Divide that by my slope, 0.089. Gives me a run of 47 feet. So I will go 45, 46, 47. Here's where my 928 contour will pass. And that is interpolating where the even contours fall between points. Let's look at this next triangle down. So I have 923.81 where I just came from. I'm going to look at the center line, 928.89. It looks like I will have the 924, 926, and 928 contours again. So for this triangle here, 928.89 minus my 923.81 gives me a difference in elevation of, oh, that's actually the same one over here. That's the same elevation. So, hey, look at that. So we can go, was that 2 feet? And then what was that, 24 and change? And then was that 47? Yeah. So here's where my 926 falls, my 928. This is a process we're going to want to complete for every side of every triangle we have here. The math is not that terribly difficult. We just have these two equations, rise over run equals slope, rise being your horizontal distance, your horizontal rise being, rise being the change in elevation between 2 points. Run is the horizontal distance between 2 points. And the slope is basically the rate of change between those 2 points, the rate of change in elevation. So once you calculate your slope, you have that. Now you just solve for the rise being, you know what contour you're trying to find. How about if I do this one here? 923.90, we'll go from center line to center line. 923.90, 928.89. 928.89, 923.9 minus, that gives us a rise of 4.99. What's my run? 57 feet. Equals a slope of 0.0875. So I'm going to try to find my 24, 26, and 28 contours again. 924 minus 923.9 is a tenth of a foot. Divide that, that's going to pretty much be right there, 1 foot away. Here's my 924. Okay, 926 minus my 923.9. I have a rise, a change in elevation of 2.1. We're going to divide that by the 0.875. Gives me a distance of 24 feet. $926. Okay, how about 928 minus my 923.9? I have a change in elevation, the difference in elevation of 4.10 feet. Divide that by my slope, 0.0875. 46.85 feet, I'll just say that's 47. So right there, 928. So that's where the contour falls on those lines. Once you go through and do this, you're going to find where's your 924s, your 926, your 928, 30s, 32, 34. I don't think we have anything higher than that. We won't find a 36. You're going to go through, find those, and then once you find all of those, what we're going to do then is connect the dots. Now, I would recommend using like a dashed line type. Just a simple so here we'll connect. And that's how you find the actual contours. Now, let's go ahead. Yeah, what the heck? Let's do. We can go do another one here. So, like, say the center line here. We have 924, 926, 928. So between these 2 points, I have 933.16 and 928.89. So what I would have here would be the 930 and 932 contours fall between these 2 points right here. (933.16), my 1 point here. My other point, the difference in elevation between these 2 points, 928.89, gives me a rise, a change in elevation of 4.27 feet. I will apply my scale here to find my run. That looks like 49 feet. So I'll divide that. I'm coming up with 0.087. So 930 would be the next one we solve for. 930. I'll write that one down somewhere. 0.0871. Okay. And 930 from 928.89 gives me a difference in elevation of 1.11. We're going to divide that by our slope, 0.0871. Divide. Gives me a distance of 1274. My run. 1274, almost 13 feet, right there. 930. How about the 932? 928.89. I have a difference in elevation of 3.11 divided by my slope, 35.7 feet. So almost 36. Let's look over here. So 933.16. Let's look between these 2 points, the center line and this edge of pavement up here. 933.16 and 928.89. My difference in my elevation between those 2 points. It's 4.27 feet. My run, which I scale, is 49 feet. 0.0871. So this road, as we see here, is at a pretty constant grade, pretty constant slope. So what is my 930, 928.89, 1.111 divided by my slope, 0.0871, 12.74 feet. This is pretty much going to fall almost right like the last one there. (932) minus the 928.89, 3.11 divided that by our slope of 0.0871, 35.7, almost 36. Here's my 932. And just for the fun of it, let's go ahead and do this one. 933.13 minus, I'm going to go between these 2 points, my edge of pavements. 933.19 minus my 928.89. My rise, my difference in elevation is 4.24 feet. My run, let's throw a scale on that, 49 feet. I get a slope of 0.0865. Okay, let's find that 930 contour. 930 minus my 928.89. I have a difference in elevation of 1.11. Let's divide that by my slope, 0.0865. And I have a run of 1283. It's almost 13 feet. 10, 11, 12, almost 13. There's my 930. Then 932 from my 928.89. Rise of 3.11 feet. Divide that by the slope, 0.06, or I'm sorry, 0.068. 35.95 feet. Close enough to say 36 for this. There we go. Here's my 932. So we'll connect the dots here. Now, these dashed lines, I did this particular spacing. I want to keep that consistent with my 2, 4, 6, 8 contours. Now with the 30, this is an index contour. I want my line type to be different. What I'm actually just going to do is a longer dash. So I have on my intermediate contours, every 2, 4, 6, 8 contours, a short dash line. My index, which is going to be just the 930, I'm going to do a longer dash line for that one. So again, you're basically going to do this for every single side of every triangle. Look between each one, say, okay, here, what do I have contour-wise between these points? There will be some where you may not have any contours between them. I'm looking to see, I got anything kind of flat-ish? Between like between these two ground shots here, I have 930.64 here, 931.34. Well, the 930 is not going to be in between these 2 points, and the 932 is not going to be between these, so you really have nothing in between here. 930, 64 over here to 932, you will have the 932 contour, so you only have to find one here. Between 3273 and 3284, you have nothing in between there. Between 32 and 33, you have nothing. So not every single one of these is going to have something, and not every single one is going to have 3 contours. You may find 1, you might find 3. The math is not too crazy difficult. It is going to be time consuming, not going to lie. But that's the gist of this. I'm not going to do the whole thing and bore you with a whole couple hour long video, but this is getting started. Again, remember your calculation here, rise over run equals slope. Rise being your change in elevation, run being the horizontal distance. Slope is the rate of change in elevation. Once you find your slope between these any two points, You know what contour you're going to be looking for. So you have your contour you're looking for and your beginning line elevation. So now you have your rise, you know your slope, you calculate your run and measure that out. Any questions on that? Ha, just kidding. Sorry, you can't answer during a video like this. But that is the general gist of what you want to do to interpolate contours.